Hey everybody, welcome to a new video. It's been a long time since my last video, and I'm sorry I was busy like everybody and didn't have really the head to make a video. But back I am with this video about how to translate a ShaderToy code into a Max shader code. Now this question has been asked to me several times, so I thought in the end, let's just make a video that should clarify how this is done. This can be done for every shader in ShaderToy. If you know, ShaderToy is a crazy cool website where there are a lot of amazing shaders, which are mostly built using techniques like ray tracing and signet distant function in order to create some visuals. So for example, everything you see in this image is generated in real time using some mathematical formulas, some shader functions that place the color of every pixel in the scene to a certain color in order to render a scene that makes a visual sense. So it's a super cool source of inspiration. Most of the math behind this stuff is beyond me. I'm trying to learn, but takes some time. So there are also some amazing tutorials on YouTube on how to, not from my channel, but from other channels, on how to start creating shaders in the ShaderToy fashion. But if you simply want to put one of those shaders inside your Max application, inside your Max program, this is super simple and we are going to see how to do that. Well, first of all, let's create a new patch. As you can see, I already created a new patch. And I've just added a JIT world with some basic parameters. Actually, the camera we don't need. So some basic attributes for the JIT world, like full scale anti-aliasing is also not necessary, size doesn't really matter, raise all this stuff doesn't really matter apart from full screen menu bar that you can choose if you want to have the menu bar when you go full screen or not. And then the fragment, the frame rate, which I keep to 120, which is kind of the maximum for the screen of my computer. So first object we need is our dear object jit.gl.slab. Messing a bit with the zoom, sorry. So let's go to fair 125. So it's the jit.gl.slab object. I give it the name of my context. Maybe this is still a bit too small. Okay. So the name of my context, which is game. And yeah, then what we need is to create a texture. So jit.gl texture, also the name of the context, and let's give it some dimension to this texture. Let's make it HD. Now I could have also used a matrix to feed the jit.gl.slab, but I'm actually using a texture because a texture already resides on the GPU, while a matrix resides on the CPU. And so it's actually much better in performance terms to use a jit.gl texture to feed the jit.gl.slab. This is basically just what comes inside. It's actually an empty texture and will be the color of the pixels of this texture will be set inside the jit.gl.slab. So this we need in order to feed the jit.gl.slab. If you're getting a bit confused with this texture and GPU stuff, you can go on my website, and I have here a tutorial about textures in shaders, which should clarify it. I will put a link in the description of this tutorial. Okay. So back to the patch here. Okay, so actually we need also to connect it to the metro in order to generate a different frame every frame, a different picture every frame. So I have here a sender, which sends the bangs from the center of JIT world, and here a receiver, which receives it, triggers the thresher, which triggers the shader calculation. Now, to visualize it, we need something like a video plane with the attribute transformer z2. This will occupy the whole screen. So boom, this we have our basic empty texture basically. So this is how an empty texture looks like. Now, if we double click on the jit.gl.slab, we can see that a shader appears, or already like a kind of a default shader appears, which doesn't do much, just reads the texture, which in this case is this empty texture. For example, we could set it to the color of our picture to a single color. But first we have to save this file, so I will save it on the desktop, calling it ShaderToy to max.jxs, which is the format in which shaders in Max are stored. Okay, so JXS. I save it, and now this shader resides inside the jit.gl.slab, and we can see that we are, for example, drawing color inside the window, changing the glfrag color variable. Okay, but the thing is that this is a bit small, so I would like to edit this shader with Atom. So in order to do that, let me first give it the name of the shader onto the jit.gl.slab object. So this was called ShaderToy to max.jxs, I believe. Yeah. Okay, perfect. So I will take this shader, which is here, and I will open it with Atom. Okay, then let me select the syntax. You can download the syntax for GLSL for Atom from the package manager of Atom. Atom, as you can see, is just a simple editor for several programming languages, and I'm choosing the GLSL syntax. So the stuff that is relative to the JXS Max wrapper, it's not highlighted, but everything that is relative to the GLSL syntax is highlighted, like vector, barring, and so on. Now, yeah, we can edit this shader from this Atom editor. Now, let's go back to the ShaderToy website. Let's just pick a shader. Let's pick, I don't know, let's just pick the first one, okay? And okay, so seems quite okay. We should be able to translate it without problem to Max. So I just select everything with Ctrl-A, Ctrl-C, copy everything. I go inside my shader here, and I select everything that regards the void main function, and I replace it with the code that I just copied. So all the code that I copied, let's actually delete these comments here. All the code that I copied is replacing the void main function. Okay, let's do it again for clarity. I just take the void main function, so the main function, I replace it with the code that I copied. Okay, so once we are here, there are in ShaderToy, there are some basic uniform that come already from ShaderToy, and we have to provide them to the shader if we want to have the same result as ShaderToy. Now, the default jit.gl.slab shader gives already like a couple of parameters. It gives this scale and this text 0, which is basically the texture that if we want to read a texture inside a shader, we can use this text 0 uniform. But what we want to do is to create a parameter called iTime, which is the time in ShaderToy is the time passing, which is used to animate the visuals. So we have to bind it here to the fragment program, and yeah, then we go back to our fragment shader. So sorry, I'm only working on the fragment shader for the moment, okay? So everything we did was in the fragment shader. So the void main function was relative to the fragment shader. And then I replace this scale here with iTime. So this is set. Then we need also to replace this built-in variable from ShaderToy called fragchord. This is actually glfragchord in Max. And then high resolution is actually the dimensions of the texture. So the dimensions of the texture, we can simply hard code them, because we know how big is this texture, but we can also get them from the vertex shader. So in order to do that, we go on our, in order to get the code to get the dimension of the texture, I just go in the file browser and we look for true in the file browser. And we have to get this sh pass-through dim vp.gl.slab. Double click on it and you can see the code to get the dimension of the texture. So basically let's take this one, text dim 0. Let's go back to our shader code, and now in the vertex shader, after text code, I will just write text dim 0. So this we can close. And then we have to pass this variable to the fragment shader. So we have to create a varying variable. Let's call it high resolution. So we don't have to rename everything inside the fragment shader. We just use the same name that comes from ShaderToy. And now we have to add this varying variable here. So this we can close. We don't need it anymore. And this should be actually it. So I double click now on the jit.gl.slab, save this code, and let's see what happens. We probably got an error. So implicit cast from vec4 to vec2. Okay, so there is probably something wrong. Oh, frag color, actually in the end I also have to call GL. So this is basically our output from the fragment shader. In Max is called GL frag color. So again here, let me save. Oh, okay, now it saved the previous one. So GL frag color. Let me save, and we still get some troubles. And oh, actually our shader has a different name, sorry, so I was wrong. This is actually called ShaderToy 2 Max, not strange that it was reading it already. So we're still getting these implicit casts from vec4 to vec2. Let's actually, instead of reloading, instead of saving inside the file every time, let's actually copy the name of the file inside a message and pass the file attribute. Oh, and sorry, I forgot to rename actually the void main image to void main and void, like is done in the Max fashion. And as you can see, this actually works. So, okay, now is reading our shader. Is not animated because we are not passing the time to the shader. So to pass the time, we can use a clocker object, make it by default active, and divide this by 1000, so we get actually the milliseconds instead of the seconds, and then we can pass it as a message param itime $1. So this will now work. Now this is actually already divided probably in the code. Oh, this is too much. So let's, I don't know, divide it by 100. That is too fast. But you get the idea. You can adjust it as you want. Now the only problem is that when we resize our window, the proportions are going to be messed up. In order to deal with that, we need actually to get the sides of our window. So get sides from our window. Let's, I don't know, get it every once 2 seconds. So once every 2 seconds we get the sides of our window. Let's route the sides from the output here, and we get the sides of our window. If I manage, okay. So now we need the ratio of our windows, so we just can divide these numbers one for the other and send these as a parameter to our shader. So like that. And now we have to create this parameter inside our code. So I just will copy the time parameter that we created before. We call it ratio, and yeah, it's a float, default one. I have to bind it also here to the fragment shader, the fragment program. And then we can use it inside the fragment program. So let's just go here. And not in the vertex. This was the vertex shader. Let's go in the fragment shader and create a new uniform float ratio. And I believe we have to multiply the coordinates, the UV coordinates, the x component of the UV coordinates for this ratio in order to have always the proportions. Good. So yeah, as you can see, it works. Even when I resize my window, after a couple of seconds, the ratio will get back to the normal proportions. The proportions, sorry, will get back to the normal ones. Okay, so this was quite fast, was quite easy. So this is how you can translate a shader from ShaderToy to Max. Remember to create the high resolution, which is the dimensions of the texture. Then the high time, which you can pass as a floating number continuously increasing. And then we get the ratio, which is the ratio of our window. We need to keep the proportions right. And then you have to change the frag color into GL frag color. And you have to rename the main function into void main void instead of what comes from ShaderToy. And that's it. That's all you have to do. Okay, because everything else is the same inside Max and ShaderToy. Okay, I hope this video was helpful for you. And if you wish, you can support me on Patreon, which is a cool way to support me and my tutorials. And you also get a lot of patches which I did in the past and which I will go on making in the future. But thank you for following and see you on the next tutorial. Ciao guys!